Skye is going to talk about the radio SkyPipe software and also do a little demo.
I hope if you don't mind us sit down. There's a couple of reasons for that. One is I'm not hooked up to this other computer, and I need to manipulate my computer at eye level here. And the other is that I have panic disorder, and so right now you all look like a lot of hungry lions to me. So I'm going to sit down. We'll see how this goes. I'd like to take. I can use more. I'd like to take a little poll here. First thing is how many of you are Windows people? You consider yourself a Windows. You might have Linux, but you're a Windows person. Wow, that's wonderful. Now,
no, it's not.
Okay, and I guess we know who's going to answer the next question. How many use Linux as your main thing? Not just something that you do for fun. Okay, all right, it's pretty small. And then what about Mac users? Okay, yeah, okay, those are the artsy folks. Okay. Then one last poll, and I don't know, somehow I thought I could adjust my talk for this, but really I won't. But how many of you use radio SkyPipe now? You already do. So most of you are familiar with it, and there's not a lot of reason for me to go into great detail, but let's just go over the basics for those who are not familiar with the program. A radio SkyPipe is a script chart, a software-defined script chart recorder, and it plots amplitude over time. And it doesn't have to be a radio signal. It could be anything that you present to the program. It just tells you how strong your signal was at any given time. And we've been using script chart recorders since we've been doing radio astronomy. That's Carl Jansky back in 1932 in a publicity photo. I can't believe it. It's anything but. He's just pointing to a chalk drawing up there, looking at his chart going, ooh. So, but anyway, he used script chart recorders in his initial studies. You might have seen some of those. I think somebody showed one in an earlier talk. Radio SkyPipe is not intended to sample at high rates. It's 50 samples a second is maxing it out. But we don't need it for Jupiter. We're good at about 10 samples per second to see the fine detail. You can use a sound card to get your data into radio SkyPipe from the receiver. Or you could use an ADC input, analog to digital converter input, and we used to do that pretty often. We detect the sound outside of the computer and then produce a DC voltage and then measure that. But the sound card accomplishes pretty much the same thing. And with the radio SkyPipe, you can share in real time over the network. That was one of the main things that I think the Jove program found attractive about it, was that you could look at somebody else's chart in real time and verify what you were seeing on your chart. There's a little chat feature. We used to get together late at night, and we'd be looking at each other's charts. You might have 4 or 5 charts up, and then we would talk to each other. This is before the telecom line, in the little chat window, and say whoopee, and there's Jupiter. But it's great for verifying what you're seeing. Yeah. Okay, you can record wave files, so you can record what you're seeing, or what you're hearing through your receiver can be recorded. That's not something that goes on all the time. It takes a lot of of disk space to record, it's like 1.4 meg per minute. I guess that used to be a lot of disk space. You can do easy uploads to the Jove archive and use the one-step calibration process, which we'll show you in a little bit. And one last feature that you should know about is that you can apply math functions to the data as it comes in before you plot it. If, for example, you had two channels of data, let's say you had a temperature-sensitive situation, and it's not the case for Radio Jove, but you could put a thermistor controlling one input and subtract out the temperature drift from your source, your real source of data, on the other input. In other words, you can interact between channels. There's up to 8 channels can be recorded at one time. If you don't have it, there's a free version. It's fully adequate for Radio Jove, and you can download that from my website. It has most of the features that Radio Jove users find most useful. When you buy a kit, on your CD, you'll get a little upgrade passcode that you put in and bring out all of the magic stuff. And one thing I'd like to suggest to you, that one of the first things that you should do, and lots of people fail to do this because they just want to get going, set up your identity in there. Let people know who you are, where you are. That is what makes your data valuable. Metadata is data about data. And I've gone to a great extent to try to put lots of metadata into radio SkyPipe files, and please take advantage of that by putting your name, location, that kind of thing in there. Now, one problem that's come up recently quite often is modern laptops often have very peculiar sound cards, internal sound cards, and they're made for listening to music mostly. They're not very good recording. They don't. Some of them have terrible offsets, and some of them you can only use a microphone input, which has lots of its own problems. Like it can have AGC on it. And so even though you go all this trouble to get your receiver to disable the AGC in the receiver, you send it to your computer applies AGC because it thinks you're not talking to a microphone loud enough. So I'm suggesting that people buy a little $14 USB card for that situation. And this is just one I snagged from eBay, but I know that this particular one works. And it has an official line input in there. So you can stick in 2 channels of audio into it, and it won't be messed up by microphone processing in the sound card. When you get your sound card set up and you have everything plugged up, make sure that you're set to like 11025 or 12,000 hertz. That's fully adequate to cover all of the audio bandwidth that you're going to be recording, and it makes it a lot easier on the CPU to handle that. Use the line in if you can, not a microphone. We just went over that. And make sure you go back and mute any other inputs. Like you've been recording and all of a sudden you say something, oh, that's great, and then you notice it goes, whoo, and it's like, well, it's because you said, oh, that's great, and the internal microphone is on, and it's putting data in there too. So, one of the harder things that people come up against when they install a radio SkyPipe is the networking. It's peer-to-peer. So you're talking to someone, they have to be able to find you. There's a facility within the program for that. But you have to allow them to connect to your signal. If you're a server, if you're sending out your radio SkyPipe signal to other people, then they need permission to come in through your router, and that router needs to know where to send that signal to which computer on your network. So you need to configure that. I'll do everything I can to help you with that. There's help on the website. Sometimes it just can't be done, but almost every situation, there's a way to make it happen. Okay, and I want to do a little demo. It's not going to completely finish because we're not hooked up to the network here, so I can't actually upload some files. But this is a feature that was put in Radio SkyPipe in recent years because we wanted more people to contribute to the archive. And the present interface for the archive is a web interface where you have to type things in, find files, press buttons to make your files go up. But there's actually a much easier way to do it in Radio SkyPipe. So let's see here. So I'm going to switch over here. And I am going to recently loaded. Unfortunately, I didn't have any good Jupyter files on here. So I've just got a file of somebody's interferometer. This is Hans, I don't know how to pronounce his last name. I think it's Mitchmeyer from Australia. He's been doing radio astronomy for a long time, and he has some beautiful, beautiful charts that he makes with his interferometers. While we're at it here, this is what I mean by metadata. So now when I pop up his file, I see there's something in every column: author, location, the name of his observatory. And he has gone that extra step that I wish everyone would to describe their observatory and what the kind of equipment they're using. That adds so much value to his data. A person can actually come to some kind of conclusion about the real nature of what he was watching because he's described the equipment that he's using. And lastly, there's a metadata that the program automatically puts in there that you don't have to. Well, the email one is a new one, but for example, we can see that this file has been modified twice, and thus does not completely reflect the original. It might be just a little chunk of the original. For example, sample period, things like that. If you hook up to Atomic Clock, it'll tell you when you actually made a clock correction on your computer and that kind of thing. Okay, so let's get out of it. I'm going to expand this a little bit. Let's just pretend like these little wigglies here are Jupiter in the middle. This is actually a nice interference pattern on his network. So, and this is the end of the day. I see Jupiter on my chart. I go over here, I grab a zoom box, and I just put a little box around the part of the chart that I'm interested in. There. Now, this is the part that I want to send to the Jove archive. I right-click. I go Define Event. Oops, no, that's not what I do. I do Define Event. I just clicked the wrong place. Okay, let's try that again. Okay. All right. Find that. Okay. Now what's happening right now is the computer is generating a small image just of that portion of the chart, if you had recorded a wave file on this, it would actually excise that portion of the wave file that corresponds to the chart, and then it takes the raw data only from that part of the chart and puts them all into separate files. Now you could add some text here if you wanted to, like I say, this is good. Okay. I don't have a Mac. I'm not that creative. Okay. And then save it. All of these files get saved into a little folder underneath the observations folder. Yes, I want to save it. Okay, now all you have to do, you press this submit button, and this screen will pop up. You see it's all filled in. You don't need to fill in any of the start dates and times and all that. That gets filled in automatically. You will have to set up a password with Lynn Garcia, and so that you can submit your data to the archive. And if nothing changes, you can just hit the submit button and you're ready to go. Or you could set up several profiles if you had multiple receiving setups, so that it would put in the right antenna, or you might set one up for Sun, one for Jupiter, so you don't have to change the object, that kind of thing. Hit submit, and it fails. Because we're not hooked up to the network. But it automatically uploads everything, and you're done. The whole process, once you learn how to do it, it's very, very quick. Just a few mouse clicks. I hate typing. Okay, so let's go back here. I think I'm about done.
Hey, Jim, what are the units on the y-axis?
Well, I didn't look to see how he has it calibrated. I don't know. Now, this chart, normally the chart, when you're looking at a sound card, those are just the values that come from the ADC and the sound card. Somehow that's been tagged as called the SkyPipe values, and that's just uncalibrated. But we're going to show you in a minute how to change that into something more meaningful, and into degrees Kelvin antenna temperature. So let's see here.
Does it pull the time from the Windows, from your computer, and do you use a time server like Mindberg or Dimension 4 or something periodically to?
There is a, well, I'll show it to you really quickly. SkyPipe has its own, we're not hooked up to the network, so it's not going to work, but it has its own little SNTP clock thing, and you can set that up to adjust the time however often you want. Usually it does no good to try to set it to get closer than 5 milliseconds or 10 maybe. That's probably about as close as we're going to get with this system. We're talking about ways to put GPS on one of the channels, a GPS pulse and that kind of thing to help get more accurate time. Or you could run your own Dimension 4 or whatever in the background, whatever you wanted to do. Let's see. I think we're about done here. Let's see if there's one more slide. Okay, here's just a couple of things that you might not know about the program. It's several thousand lines of code, and it's a VB6. And VB6 is an old language. It's an old language. It's no longer supported by Microsoft, but it works. And in my estimation, it works just as good as VB.net for most things, not for everything. And once it got started, I'm on the same, in the middle of the same avalanche that a lot of businesses are. You don't have time to stop and rewrite a big program in another language. So so far it's just continued on. I hope to move it over to a more modern language, in the next couple of years. But so far, it works all the way up through Windows 8. They have not obsoleted it yet. It's still supported. They will, because they don't want people using this. They want people using .NET. You can define your own data sources. We'll talk about that just a little bit more in a minute. That means almost anything can be input into this script truck program. And I know people that use it to measure their heating systems in their house. There's a built-in observer log it's got quite a few functions. You can do screenshots in it, very useful. An audio spectrum display, chart. Okay, I'm almost done. You can put notes on the charts, and you can trigger events depending upon different values that come in the chart. So, for example, if you went over a certain threshold, you could say, oh, you could turn a relay off, disconnect your antenna, and think, okay, maybe I've got lightning going on, whatever. And then we talked a little bit about applying equations. More recently, I put in the ability to chart the peak frequency. So you could use a voltage-controlled oscillator, for example, for an ADC, if you wanted to. Let's say I've got something that is working at DC, that won't go through a sound card. You could have that go to a voltage-controlled oscillator, or instead of a regular ADC, and chart the peak frequency, pulse count, and there's an experimental cross-correlation detection in there where you can put signal from one receiver on each antenna and combine them in radio SkyPipe. I don't even know if it works because I don't have that set up, and I've been trying to put it together for a couple of years and never have had the time or the place to do that. And so anybody wants to do that, let me know, and I'd love to work with you, and we can debug this. And that's it. Oh, there's some of the things that you can plug in through a UDS. Almost any ADC, several computer multimeters will work, and even Arduinos, you can make them communicate over a serial port. And Dick's going to talk a bit about calibration, and then I'll show you the calibration procedure when he's done. Are there any more questions?
Any questions for Jim right at this moment? Can you switch over back to the main PC here?
Yep.